2023 has been the year of large language model, where we see multiple different breakthroughs at a weekly basis. It really created a paradigm shift that AI can also do creative, innovative work rather than just repetitive, boring tasks. And with all those developments, we'll be able to see the same level of takeoff in robots and embodied AI. The numerous smartest people in the field are betting big on robotics for 2024. Jim Fan, who is a senior AI researcher from NVIDIA, predicting we are 3 years away from the ChatGPT moment for physical AI agents. As in 2023, there are a huge amount of foundation and platforms has been built to enable robotic development, from multimodal large language model like GPT-4v that can work with normal robot arms. And we start seeing algorithms that can bridge the gap between System 1 and System 2 thinking for robotic AI. And also insane amount of progress on robot hardware. And Brad Atcook, who is the CEO of a leading robotic company called Figure, also posted a tweet a couple of days ago where he said, last 90 days, I'm watching robots perform complex tasks entirely on neural nets that he didn't think was feasible until the end of the decade. At the beginning of 2022, he believed that we'd have reliable humanoid hardware way before we can have reliable AI that can control the robots to complete household tasks. But now that thinking has really changed. He feels strongly that we likely will have reliable AI and hardware at the same time. And 2024 will be the year of embodied AI. On the other hand, I'm sure you're all seeing this impressive demo from Mobile Aloha, where they built an impressive mobile robot hardware with less than $30K, which can already complete numerous household tasks like washing clothes, cooking egg and shrimp. Although most of those tasks are actually cloned by humans rather than done autonomously by the robot. But we also saw some more autonomous examples from leading AI robot company like Figure, where a robot can actually use coffee machine to make coffee autonomously with voice control, as well as Tesla robot, where they showcase impressive hand coordination movement. So this start got me thinking, what has been the key breakthrough in the robotics AI past few months, and how far we actually are from deployable human robots? I did a bunch of different research and would love to share these findings with you. So let's get it. We can break down the robotic AI into two buckets. One is the physical intelligence, including how the robot can do the hand coordination to pick up items or ability to balance and walking to certain destination. And the other is cognitive intelligence. How can robots reasoning and making decisions based on the environment and tasks? And both aspects got loads of breakthrough in the past few years, especially in terms of generalization, which is how can we have general purpose robots that can do multiple different tasks instead of just specialized in one specific task. Because at the moment, robots are great specialists, but poor generalists. Typically, you have to train a model for each task and environment. Even just changing one variable like the background or environment can require start from scratch training. But as we know, the real-world environment is always dynamic and continuously changing, and it's impractical and inefficient for us to pre-program all the different edge cases. And this paradigm shift from specialist to generalist has been majorly driven by the development of transformers and large language model. Let's take cognitive intelligence as an example. There were plenty of developments in AI agents that showcase powerful decision-making and planning ability. For example, the research paper called Voyager, where they built an embodied agent in the digital world Minecraft. The agent can continuously explore the world, learn new skills, and accomplish tasks at even superhuman pace. And all those cognitive ability developed through those digital AI agents can later be transferable as we develop physical AI agents. And on the other side, we already see companies like Boston Dynamics start equipping their robot dogs Spot with large language model for better cognitive ability and deliver new experience for the end users.
May I have the pleasure of knowing your names?
I'm Matt, and that's Vache.
A pleasure to meet you, Matt and Vacha. Shall we commence our journey? The charging stations where Spot robots rest and recharge is our first point of interest. Follow me, gentlemen. Let's proceed to the rock part.
Similarly, we see loads of breakthrough in terms of robotic control, which is how can the robot learn to complete multiple different physical tasks. Back 2018, the state-of-art of robotic learning is called QT-opt, which is a method that uses reinforced learning to learn how to do a specific task well. It was quite efficient compared with the previous method, but still, with this method, we basically need to train new model for a different task, which is not efficient. But a couple of years later, April 2021, a research paper called MT-opt was introduced, which is a paradigm shift from single to multitask learning. So MTOP represents multitask robotic reinforced learning. MTOps revolutionized this by enabling a single robot to learn and execute multiple tasks by leveraging shared learning principles. This means instead of learning from scratch for every single new task, the robot can apply knowledge from one task to another, much like how a chef using skills from making pastry to also bake bread. And this shared learning not only making the training more data and time efficient, it also results in robots that can adapt to a variety of tasks in dynamic environment. So it was a huge step forward, but still quite limited in many ways. And the real breakthrough happening at December 2022, where Google introduced RT1. So RT1 adopted transformer architecture. It took a nice in both inputs and outputs, which basically transforming the camera image, the task instruction it is given, and also the motor commands into a language that robot AI can understand. This represents a huge leap in the robotic learning, propelling us towards highly generalized robotic intelligence. Because now the robot's understanding of the world and its tasks become deeply integrated with language, mirroring how humans perceive and interact with their environment. This allows robots to not just perform tasks that they were directly trained on, but to generalize and execute tasks that they were never seen before. It's like giving a robot the ability to read a recipe book and cook a meal it's never cooked before. And the result is that this type of general purpose approach outperforms all the previous methods in both specialized tasks as well as unseen tasks. And this is very similar to the phenomenon that we saw from large language model, that a general purpose large language model that trained on a diverse and vast datasets can outperform specialized AI model on tasks that they were specifically trained on. And 6 months later, on July 2023, building on RT1, RT2 was introduced. RT2 combined a visual language model that is pre-trained on extensive web-scale internet data, like videos and images, with RT1, which is originally trained on specifically robotic data. And this gives RT2 a nuanced understanding of visual cues and natural language, far beyond its original robotic training dataset. And with RT2, robots now have a cognitive ability to interpret complex commands and perform semantic reasonings. They can identify different objects and even use some of the objects as tools to complete tasks, with unseen objects, dynamic backgrounds, and even dynamic environments. And again, at the heart of RT2 is the transformation of actions into tokenized strings, which align robotic control with models' linguistic capabilities. This means actions are described in a language that robots can understand, enabling it to adapt actions as easily as we form sentence. And the result is that the robot can not only excel at tasks that it's been originally trained on, but also generalize to new unseen environment with remarkable accuracy. RT2's real-world application showcased a successful rate leap from RT1's 32% to 62%, making a significant step towards truly intelligent, adaptable robotic AI. But not only that, just 2 months after RT2 was introduced, at October 2023, Google announced a massive robotic training dataset called OpenX Embodiment Dataset. It is collaboration across 20 different institutions to get data from 22 different robot embodiments, demonstrating more than 500 skills and 150,000 tasks across more than 1 million episodes. And as contrast, RT1 was trained on only 700 tasks. So this is a massive training data set, and more importantly, it is collected from 22 different robot embodiments. And then Google introduced RTX, where they trained RT2 and RT1 model with this massive new diverse dataset. And by just having more diverse and bigger datasets, outperformed RT2 by 300% in emergent skill evaluation. It is crazy that those level of improvement happened just within 2 months' time. And most importantly, it is following the scaling law, which means with bigger, more diverse dataset, you get those improvements in terms of performance for free without any fundamental change. This showcasing how important training data is for robotic AI progress. And just as I'm making this video, Google just released a few new announcements for robotic AI. One of them is called AutoRT, which is a method that can potentially generate huge amount of training data from real world. It basically uses visual language model and large language model to observe different robots to continuously complete different tasks and use them as shared training data. It is still pretty early, but can be huge if it does generate a huge amount of training data. Last but not least, even though development of transformers and large language model made huge progress on both cognitive intelligence as well as mid-level physical intelligence, it often fell short on real low-level dexterous skills like hand manipulation. But Q4 2023, there are also research advancements that showcase potential for large language model like GPT-4 to design reward function to train robot low-level dexterous skills at superhuman level. It basically used large language model like GPT-4 to generate a reward function to train robot in reinforced learning. A reward function is a core part of the reinforced learning where it will tell the agent and robot whether they are doing things right or wrong. It's pretty similar to how you train a dog to give it a little treat when it does something right. So they get GPT-4 to initially design a reward function for certain actions. And then they will simulate this robot actions for thousands of times and send back the results in real time to large language model as feedback so that it can iterate the reward function. And the result is stunning. It is able to outperform expert human engineer on designing those reward function 83% of their benchmark, with average improvement of 52%. As this is the first time, I feel like we are finally breaking Moravec's paradox. It is a concept introduced 30 years ago by Hans Moravec, who was a leading robotics scientist. Its finding is basically it is comparatively easy to make computers achieve adult-level performance on intelligent tasks or playing checkers, but much more difficult or almost impossible to give them the skills of 1-year-old when it comes to perception and mobility. In short, it basically means problems that feels very easy to human are actually very hard for computers, like planning, recognizing someone, walking, or grabbing something. But problems that feel really hard to human are actually easy for computers, like math and logics. And the theory behind this paradox is that easy problems like walking, running, hand manipulation, it is something that had been developed by humans hundreds of thousands of years ago. They almost became part of intuition and very, very hard to translate back to computers. But hard problems like math and logics are skills that has been recently developed by humans and fairly straightforward to translate to computers. But with the recent development, finally, it feels like we are on the path to get away from this paradox that has been cursed the robotic industry for past 30 years. So those are key breakthroughs from the past few months. And with this pace of accelerated development, it let me feel really optimistic that robot can possibly have the ChatGPT moment in the next 12 to 24 months. And many leading robotic companies like Figure, Tesla, Apptronik all have planned to start deploying robots in real-world scenarios like manufacturing or logistics. And once these robots get deployed in real-world scenario, we'll start collecting huge amount of training data that can again speed up the learning curve for robots. So it is truly a very exciting time. So when do you think will be the ChatGPT moment for robots? Am I way too optimistic or too conservative? Please comment below and let me know. I hope you enjoyed this video. I will continue posting interesting projects and findings in AI. So please subscribe if you want to keep updated. Thank you, and I see you next time.